Welcome. We're going to be differentiating using implicit differentiation in this podcast. And we're going to look at 3 examples. So here's our first. All right, so it says take the derivative of e dxy equals sine y squared. All right, so we've got some chain rules in here. All right, so here we want to take the derivative e to the xy. Not only do we have a chain rule there, we have a product rule. All right, so we're going to take the derivative. Oops. Well, there it comes. We're going to take the derivative of the e to the blop, and then we have to take the derivative of the blop. We got to take the derivative of x times y. That's going to be a product rule. All right, so I'm going to write that over here. All right, so we have the first is x, and the second is y. Derivative of x, of course, is 1. And the derivative, but my u is looking a little bit like a v, isn't it? Let me write that clear. Let me make a better u. All right, so du is 1, and then dv, right, we're taking the derivative of y, so that is a chain rule. Right, so it's going to be the derivative of y is going to be 1, but then we have to take the derivative with respect to x, so it's going to be dy dx. All right, so we'll take those derivatives in just a moment. Let's look at the other side where we also have a chain rule. We're going to have to take the derivative of sine blop. And then we're going to need to take the, let me just move that out of the way. Uh-oh. How about everybody move? All at once. No, we want to move all in pieces. Well, that moved. And there we go, that'll move. Now we have space. All right, so we're going to take the derivative of sine blop, and then we have to take the derivative of the blop. And the blop is y squared. All right, so I think maybe that'll help you figure out some of these chain rules and all these different parts. All right, so derivative of e to the blop is e to the blop. It's its own derivative. All right, so that's going to be e to the xy. Then we need to take the derivative of the blop, take the derivative of xy. All right, so that's going to be, and I'm going to use parentheses here, right, because we're going to have a sum of terms because we're using the product rule, right? So we have the first, which was x. The derivative of the second is dy dx. And then we're going to have the second, which is y, times the derivative of the first. So that'll just be, come on, there we go, 1y. And we could really just write y. We don't need to write 1. All right, so this is the product rule. And that's the derivative of this part right here, of the blop. Now, oops, actually I wrote it over here. All right, so this here is the derivative, make that arrow smaller. The derivative of the blop, right, is going to be x times dy dx plus y. All right, so now moving right along here. All right, we have the derivative of sine blop. Well, the derivative of sine blop is cosine blop. All right, and the blop is y squared. All right, and so now we need to take the derivative of the blop, which is right here. And actually, maybe so that's the derivative for sine blop. This was the derivative of e to the blop, and the final derivative in this chain here, we have the derivative of y squared, and the derivative of y squared is 2y dy dx. Right? So we've got some things stuck over here. Notice dy dx is stuck inside those parentheses. Right? Also, this is not very nice here with the 2y at the end. All right, so we're going to clean this up and we're also going to distribute. All right, so right here we're going to need to distribute, otherwise our dy dx is stuck in parentheses. All right, and we also want to just simplify a little bit here on the other side. All right, so we'll distribute the e to the xy to both those terms. All right, and we usually write the anything but e first. Right, so the x is going to look much nicer in front of the e, right, rather than on the back side of the e where it might get all lost in its exponents. Right, so this is going to be x e to the xy. Yeah, let me write that nicer. And then I'll just put the dy dx at the end. It kind of looks nicer at the end. All right, so we have, so e to the xy times x dy dx is just x times e to the xy. That looks better. Dy dx. E to the xy times y is going to be y e to the xy. Right? And then that 2y needs to really go in front of the cosine there. The dy dx can be at the end, but the 2y needs to go in front. So 2y cosine y squared. You don't want anything after a trig function because it almost looks like, does that 2y belong with the y squared? No, it doesn't. All right, it's 2y times the cosine of that y squared. So we want to move that in front, and then we have a dy dx. All right, so we need to get everything that has dy dx's on one side and everything that doesn't on the other side. All right, makes sense to subtract this one here, right? And then everything with the dy dx will be on one side. Right? So I'm just going to put a little subtract. All right, so we'll subtract that from both sides, and on the left-hand side here we have ye to the xy. On the right-hand side we have 2y cosine y squared dy dx minus x e to the xy dy dx. We'll factor out the dy dx. So we have ye to the xy, not doing anything over here. We're factoring out the dy dx on the right-hand side, and we'll be left with a 2y cosine y squared minus an xe to the xy power. All we got to do, well, want to know one thing I have to do, I need more space. I can't reach the extended page. Maybe if I come over here to the computer. Nope, I don't know where that extended page, there, I see it. There we go. That's oops, maybe that's too much extended page. Let me see if I can undo a little of that extended page. No, I can't. I'm gonna, and that's way too much extended page. There we go. Let's just extend it one time. There we go. Got carried away there. Hit it too many times. All right, so now we're just going to divide both sides by 2y cosine y squared minus, should have given myself more space. I got to squeeze it in here. Minus xe to the xy. And we'll do the same thing over here. 2y cosine y squared minus xe to the xy. So, final answer, our derivative is ye to the xy, divided by 2y cosine y squared, our denominator is long here, minus xe to the xy. And that's it, all right? So if you've got any of your dy dx's stuck in parentheses, right, you're going to have to distribute so you can get it out of the parentheses. And that's all there is to this one. So although it looks a little maybe not so pretty, really, it wasn't too difficult, And if we wanted to evaluate, we would just plug in for the x's and the y's, and we'd have a number. And that would give us the slope of the tangent line for whatever point it was we plugged in. All right, so 1 down, 2 to go. Let's look at the next one. Right, so that one had an exponential and it had a trig function. This one has log functions in it. So we're taking the derivative of natural log of x plus natural log of y equals x minus y. All right, so let's just take the derivative. Derivative of natural log of x, 1 over x. Derivative of natural log of y, of course, is a chain rule. Right, so we're going to have 1 over y, but then we're going to have dy dx. Derivative of x, that's 1, and derivative of y is dy dx. Well, this one doesn't look too complicated now, does it? All right, so we need to move all the constants to one side and all the dy dx's to the other side. I think so I don't have a bunch of negative dy dx's. I'm going to subtract, or add, excuse me, the dy dx on this side and subtract the 1 over x on the other side, right? And so we'll have a minus 1 over x, and we'll have a, let's stick it over here, a plus dy dx, right? So dy dx's are going left, and the constants are going right. So to the left, we're going to have the 1 over y dy dx plus the dy dx. On the right-hand side, we're going to have a 1 minus 1 over x. Right? So dy dx is to the left. Non-dy dx is anything else to the right. All right, so now we're going to factor out dy dx. So we have dy dx. And in the parentheses, will be 1 over y plus 1 equals 1 minus 1 over x. Divide both sides by 1 over y plus 1. 1 over y plus 1. And then we have dy dx is equal to 1 minus 1 over x divided by 1 over y plus 1. Except we have a little problem here. And that little problem is we need to simplify the complex fraction. All right, so we're going to multiply everybody, our least common denominator is xy, right? We got an x in the denominator, we got a y in the denominator, so everybody's got to be multiplied by xy. All right, it still balances so long as you do it to all 4 terms here. And then we won't have a complex fraction anymore. All right, so starting at the top, nothing cancels. All right, with the first term. On the second term, the x's cancel. All right, now we're in the denominator. All right, first term, the y's cancel. Second term, nothing cancels. All right, so now all we have to do is multiply. And since I've got lots of space on the right-hand side, how about we just follow the arrow over here, all right? So dy dx is x times y times 1 is, I got xy over there. The x is canceled, so that's going to be minus y. In the denominator, the y is canceled, so this will be x. And then we'll have plus x times y. And there we go. There is our derivative. That's all there was to it. Right? So really, I think a pretty straightforward one. We just had to do a little simplifying on that complex fraction there. All right, let's try the last one. All right, so I believe the steps are in your notes as well. So step 1, we're going to take the derivative. All right, and just a little reminder here, when we have a log function, now we had a log function over here, also natural log, which are pretty nice and easy. But here we just had an x, right? So the derivative of x is 1, right? So that's why there was just a 1 in the numerator. But on over here we have We're taking the natural log of something that's not just an x, right? So we're going to have to take the derivative of what's in the parentheses, right? So natural log of x squared plus y squared, right? We're going to have to take the derivative of x squared plus y squared, and that's just going to be over x squared plus y squared, right? That's the derivative for natural log, right? And then let's take care of the x and the plus and the 4, and then we'll simplify that. Take the derivative of x squared plus y squared, because derivative of the terms on the right are really easy. Derivative of x is 1, and the derivative of 4 is 0. All right, so now let's take the derivative of x squared plus y squared, just a chain rule. All right, so we're going to have derivative of x squared is 2x. And it's only a chain rule for the y squared, actually. So when I said chain rule, it's just the y squared. Derivative of y squared, 2y dy dx, all over x squared plus y squared, and that whole thing equals 1. Well, now our dy dx is stuck inside a quotient. All right, so we're going to have to get rid of the denominator of that fraction. All right, so we're going to eliminate, as it says in step 2 there, eliminate the denominator to free dy dx from the fraction. We're going to multiply both sides by x squared plus y squared. All right, so, and it's got to be, here we're just multiplying both sides by x squared plus y squared. All right, so we have two terms here. We have essentially a term on the left-hand side and a term on the right-hand side. You could also think of it as making it 1 over 1 and cross-multiplying. It's going to be the same thing. So if we multiply both sides of this equation by x squared plus y squared, it cancels on this side, and we have, I'm going to write green. We have 2x plus 2y dy dx equals x squared plus y squared. All right, now we have freed our dy dx. All we got to do is subtract the 2x from both sides. So we have 2y dy dx equals x squared plus y squared minus 2x. And then divide both sides by 2y, because there's only one term, nothing to factor here. And so dy dx is x squared plus y squared minus 2x, all divided by 2y. There we go. All right, not too bad. And that's the end of these three problems. All right, so we just took the first derivative here. This would be a little messy as a second derivative, especially that first one. So when you're looking at the Nearpod, if you have any questions, I left a space where you could tell me if you had a question. And there, just as a reminder, there were 3 problems. So if there was something you didn't understand on question 1, right, just type in that little box there. I didn't understand question 1. If you could specify, if you could tell me what you didn't understand, that makes it easier. But if you're not sure how to explain it, then, or you could just tell me what step it is, you know, on the first step, the second step, the third step, or you can just say I had questions about question 1. This one was question 2. So if you have questions about question 2, just type it in that box. And this was question 3. So if you have questions about this one, just type in what your questions are, or at least tell me if you had trouble with one of these if you had trouble with this particular problem. If you didn't have any trouble with any of these problems, and you don't have any questions right now, you can just tell me you don't have any questions. That's fine. Right? You don't have to make up a question if you don't have one. All right, and that's the end of my podcast. Thanks for watching. Bye for now.